When bridges fail, it's most often because of extreme flood events. Based on current bridge guidelines, designers consider the force of water on the bridge's substructures, but there is little information about how these hydrodynamic forces affect the superstructures, the components that hold up the bridge deck. In part, this project, thanks to small-scale laboratory experiments, was designed to help reduce the bridge failure risk on typical TxDOT bridge decks.
So the main objective of this research was to assess and evaluate the superstructure of our bridge structures. Not to be confused with the substructure, which is the piers. Superstructure is going to be the beams and slabs. And to assess this in conditions of flooding, when the deck is being overtopped or barely overtopped, and in high velocities.
What we are trying to do, or we have done here, is to quantify these forces first, making sure that we have a good understanding of these forces acting on the bridge, and then look at the current practices the TxDOT and other state agencies have to countermeasure these forces. We look at almost 900 bridges around the riverine and coastal areas of Texas. And then we came up with a list of the forces that are acting on these bridges, the depth of the flow, velocity, the actual situation that's happening in the field. And then we try to simulate them in the lab over the bridges that are scaled 50 times smaller than the actual size.
They built a scaled model 50-to-1 of our Texas configurations. We looked at our Texas girders, or Tex girders, which are I-beams basically. We looked at box beams and we looked at slab beams. And we built models, not of all of them, but most of them, with the idea that we would also build CFD 3D modeling.
We brought all those results to computer simulation, call it the CFD, computational fluid dynamics, and then we ran more scenarios, almost 1,000 scenarios, to simulate the forces acting on the bridge and the interaction between the bridge superstructure, meaning the deck, and the substructures. And also we simulate the countermeasures, the shear keys and ear walls, to see if they have enough capacity to counteract the flood force.
The drag forces are a little greater than the structural shear key strengths. That's an indication that we can probably improve our designs, and so that's the next step, is to improve our details and our standards for bridge design.
Using the result of this simulation on our recommendation, we can make the existing bridges safer, and also we can incorporate this design recommendation in the future bridges, and basically we have safer bridges in our system.
We want to build a system that's reliable, that doesn't have maintenance issues or fail during large storms. We want a safe system, and we want an economical system.
For more information and to find the publications for this project, please visit the TxDOT Research Library at the link shown below.